Hi guys, here's notes for 2.1 day 2. We're going to be solving radical equations. So our goal in these guys is to get an answer like x equals blah blah blah. In order to solve a radical equation, our first goal is just to get the radical by itself, and the radical is like your square root sign or your cube root sign. So I want to get this guy by itself, so I'm going to move this 2 over to the other side. I get 2x plus 2 is equal to my square root. Once I move it over and I've got the square root by itself, I'm going to get rid of the square root by squaring this side. But what you do to one side, you have to do to the other side. So over here I have 2x plus 2 squared, which is 2x plus 2 times 2x plus 2. On the other side, the square cancels out the square root, and what I have left is 100 minus 12x. All right, multiplying out on the left-hand side, 2x times 2x is 4x squared. And I get 2x times 2, that's 4x, plus 2 times 2x, that's 4x. So 4x plus 4x would be 8x in the middle. And then 2 times 2 gives me 4. At this point, I see that my highest term is a 2, so I know I've got a quadratic equation. And we solve those guys generally, we try to factor them if we can. In order to factor them, we've got to get everything over to one side and get it set equal to 0. So I'm going to subtract 100 from both sides, add 12x to both sides. I get 4x squared. 12x plus 8x is 20x. Negative 100 plus 4 is negative 96. The other side cancels out, so it's just equal to 0. I can factor it as is, but I see that I've got a common factor of 4. 4 goes into 4, 20, and 96. If I divide that off, it's going to make my numbers a lot smaller, which will help with my factoring. So 4 divided by 4 is x squared. 20 divided by 4 is 5x. Negative 96 divided by 4 is negative 24. 0 divided by 4 is still 0. And this becomes a much nicer trinomial to factor. So the two numbers that multiply to give me 24 add up to 5, subtract to 5 would be 8 and 3. And I need 8 to be positive because I need a positive 5x. So 8x minus 3x. And then from here, like I said in class, if you see it, it's 8x. X plus 8 is equal to 0, x minus 3 is equal to 0. When we solve those guys, it's 8 equals negative 8. X equals negative 8. X equals 3. Those are my two possible solutions. Why do I say possible solutions? Because with quadratics, with square roots, we need to double check to make sure that these solutions actually do work. So what does that mean? I'm going to plug in 3 into my original equation and see if it works. So I've got 2 times 3, and I'm asking myself, does that equal the square root of 100 minus 12 times 3 minus 2? All right, on this side, 2 times 3 is 6. When you're checking equations like this, you never move anything back and forth. You have to keep what's happening on the left-hand side over there, right-hand side stays on the right-hand side, and then you see if it equals each other at the end. All right, so underneath my square root, I've got 100 minus 12 times 3. Well, 12 times 3 is 36. 100 minus 36 would be 64. The square root of 64 is 8. And 8 minus 2 does equal 6. True statement, so x equals 3. Good solution. All right, second one would be x equals negative 8. Let's check that guy out. 2 times negative 8, is that equal to 100 minus 12 times negative 8 minus 2? So over here I've got negative 16. On the other side I've got 100 minus 12 times negative 8 would be 96, positive 96. 100 plus 96 is 196. The square root of 196 is 14. Make sure you know your squares all the way up to 15. By that I mean 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. The way I like to remember those is 13 and 14 are flipped. 169, 196 for 14, and then 225 for 15. But we get to the final statement, negative 16 equals 14 minus 2, which is 12. That's not true. So this is not a solution. All right, Ms. Harris, I don't want to do all that work. I want to check to see if it's a solution, but I don't want to have to write all that out. Okay. I'll let you use your calculator. You guys are in pre-calculus. You don't have to go do all that algebra back. So plug it into your calculator. But you thought I wasn't going to say that, right? I'm going to plug it into Desmos here for you. And we'll talk about how we can see if it's true or not. So what we are trying to look at is we're going to graph this guy and see if what we came up with is true. So by graphing it, we're going to graph the left-hand side and see where it intersects the right-hand side. From our calculations, it should intersect at 3, but not at negative 8. So on the left-hand side, we have 2x. Oh, Desmos likes to give you trouble whenever I make these videos. 2x. And then on the right-hand side, we've got the square root of 100 minus 12x. So the square root of 100 minus 12x, and then outside the square root, we have minus 2. All right, we forgot our x here. That's why it's giving me a number. It will perform regular calculations for you, as you see. But when we put an x in there, it's going to graph it. So this is those two graphs. And you see here that our one solution is right up there when x is equal to 3. Now, if we were to extend this and we did both sides of it, that other solution is coming down here at negative 8. This is where that solution would have been if the square root had both sides to it. So that's why it's an extraneous one there. But it's kind of fun to graph it and look at it and think about why one solution works and one doesn't. All right, there we go for that one. Let's look at B. Again, our first goal, try to get that cube root by itself. So I'm going to subtract 14 from both sides. And I get the cube root of x minus 5 squared is equal to 36. And then now I want to get rid of the cube root, so I'm going to cube both sides. I don't know what 36 cubed is. You guys told me in class, but I forgot already. Go grab my calculator. I guess I could have gone back to Desmos. Here we go. So over here, the cube cancels out the cube root, and I just have what's inside that house, which is x minus 5 squared. On the other side, I got 36 to the third power, which is 46656. All right. Now I'm still trying to get x by itself, so I'm going to take the square root of both sides. And so I get x minus 5. Now when I take the square root of something that has a variable in it, it's plus or minus the square root of x minus 5. When I take the square root of a positive number, it's just going to be a positive number, in this case 216. So I have one equation, x minus 5 is equal to 216. And the other one is negative times x minus 5 is equal to 216. So over here I get x plus 5, 216 plus 5, I get one solution, x is equal to 221. On the other side I get negative x, negative times negative 5 is positive 5. I subtract the 5, negative x is equal to 211. And then I would divide by negative 1. I solved it a little differently in class, but I think this really explains to you that this guy stays positive, whereas this one, because it's a variable, that's when the plus or minus comes into play. So we think we have two solutions, 221 and negative 211. Let's see what Desmos has to say about this one. So we want the cube root, which Desmos won't do, but we can make it into exponential form. So I want x minus 5, I'm going to rewrite that as x minus 5 to the 2/3 power plus 14. So x minus 5 to the 2/3 power plus 14. I'm going to put it in rational exponent so that I can plug it into Desmos. So here I've got, in parentheses, x minus 5 raised to the 2/3 power. And then what did I say, minus 14, I think? Let's see if I'm right. Oh, plus 14, that's why we always go and check, because I'm usually wrong. I used to have a really good memory, guys, I promise. There we go. And then on the other side, let's see what we have. On the other side of our equation, we've got 50. Doesn't that make a really interesting graph? Now we said that around 230, I feel like I'm missing something. Oh no, we just want to know when is this line here equal to this line at 50. So when does it cross y equals 50? So if we are tracing our graph, we want the y to be equal to 50. So this guy is going to be equal to 50. Whoop, it was right there. 221. So that solution works. And we need this guy to equal 50. We said negative 211. There we go, negative 211, 50. So both of those solutions work. We could plug it in and do it algebraically, but I'm happy with you guys checking out your graph because I think it's really important when you're graphing these things, you're getting to see what the graphs really look like, which I think is helpful for your understanding. So there's 2 of them. When you come back, I've got 2 more examples for you, and then I'll make a third video with 2 more examples. I don't want these guys getting too long. So thanks for watching. Come back.